Check, check. Here we go. Welcome back, Physics fans. And here is question number 30 on Physics 12 projectiles. A golf ball is hit at 25 meters per second at an angle of 20 degrees. How far does it travel before landing on the ground? So it is assuming level ground, and it's a projectile that's pretty shallowly launched. It's at a speed of 25 meters per second, angle of 20 degrees. I didn't show accurately there. So we have a range formula that we just developed, and that's what it's asking for, is how far. And how far something travels horizontally is the range of a projectile. Range is equal to v squared over g times the sine of 2 theta. So this is going to be 25 meters per second. We have to square that. We have to divide that by 9.8. And then we have to do the sine of 2 times 20. So 2 times 20 is 40. So we just plug this into the formula. And we get 25 squared divided by 9.8 times the sine of 40. And that will give us our range. Okay, and that answer was 40.994. All right. Now here's an advanced question for 30B, although that's our answer in less than a couple minutes. 30B, what other angle can he hit the ball at, still at 25 meters per second, to land at that same location? In other words, I want him to chip it and it'll go high and it'll come back down and land at that same location. Okay, well, it's still v squared. I'm not saying he's changing that. He's only changing the angle. He can't change gravity. It's still going to have the same range. So we want the sine of the function to be the same. The only thing that we're doing in there is changing the angle. So let's just rearrange that if you need to with me. Okay, the range is still going to be 40.994, and we still want it to be 25 squared all over 9.8, just the range formula. And then we still want to go sine of 2 theta, but now I'm saying give me another angle, because 20 is going to solve this. So if we go through all this, if you want to, here we go, multiply this by 9.8, and then divide it by 25 squared. That means the sine of 2 theta has to equal 0.64278. So we'll just do that. So 0.64278. So now I have to find out that 2 theta is equal to, now inverse sine to find out what that angle is going to be. So I'll now inverse sine that number, and I get 40. So am I only getting that theta has to be 20 degrees? Well, there's another option. Okay? We want the sine of 2 theta to be equal to this ratio, but there are actually in trigonometry an infinite number of answers for this. First thing that we need to know that sine is positive in both quadrants of 0 to 90 and 90 to 180. It's negative down below all the way back to 360. So we have a reference angle here of 20 degrees. Oh, sorry, 40. 40 degrees. So there's another angle over here has a reference of 40, and that is going to be 140 degrees. So the sine of 140 is equal to the sine of 40. Let's just verify that. You should know this from our trig, but the sine of 40 was 0.64278. The sine of 140 is also that same number. Okay, so this is another solution. And if this is 2 theta or this is 2 theta, that means 70 degrees here and 20 degrees here. Solve it. So if I put in 25 here, 9.8 here, and 70 here, I will still get the range of 40.994. Let's just verify that. We're just trying to understand the multiple answers that are coming up here. So 25 squared divided by 9.8 times the sine. So I'll multiply that by the sine of 2 times 70. Close the bracket. So that's going to come up to 140 in there, and take the sine of the 140, and I'll still get the 40.994. So there are 2 answers for projectiles landing at the same point. And these numbers have to be that the 2 thetas are the same, and that's 140 and 40. So that means these have to be half that, so they have to be complementary. These two have to add up to 90. So part B could have been really easy if we understood that. And I said, what other angle does it land at the same spot? You would have just gone 90 minus the 20-degree angle and got 70. But I just went through the whole mathematical proof of that. Thank you very much. Subscribe. Enjoy.